So let us say the particle is moving in a circle. Let's assume the particle to be moving in the counterclockwise direction. So we do not know whether the angular velocity is constant or not. In fact, in the most general case, we are not assuming it to be constant. We will do calculus based analysis. So the position vector of the particle is given as r bar is equal to, so capital R is the radius, so r bar is equal to r cos theta I cap plus r sin theta j cap. This is simple vectorial analysis. If we do differentiate r bar, then we are supposed to get the velocity, which we will do right now. So velocity vector is equal to dr bar by dt is equal to, so here r, capital R and I cap are constants, so the only variable is cos theta that we need to differentiate. So we get r I cap, the derivative of cos theta is minus sin theta, and by chain rule, because we are differentiating with respect to t, we'll also have to write d theta by dt. Similarly, differentiating the next term, we get plus r j cap cos theta, the derivative of sin theta is cos theta, into d theta by dt. So this d theta by dt we already know is defined as omega. So this is the instantaneous omega. So we get velocity ultimately as r omega, d theta by dt I am putting as omega, minus sin theta I cap plus cos theta j cap. Now this particular quantity minus sin theta I cap plus cos theta j cap is an interesting quantity. So it points in the tangential direction, because as you can imagine, the I component is negative and the j component is positive, so intuitively you can observe that it points in the tangential direction. It can be exactly shown to be pointing in the tangential direction as well, because it happens to be perpendicular to the blue radius vector. So this quantity also is a unit vector because its magnitude is 1 under root of minus sin square theta minus sin theta the whole square plus cos theta the whole square happens to be 1. So basically this quantity is a unit vector that is pointing in the tangential direction, and hence this quantity can be also labeled as t cap, the tangential unit vector t cap. So the velocity could further be written as r omega, both of which are scalars over here. So omega represents the magnitude of the angular velocity over here, and t cap, which shows us the direction of the velocity. So this is an important equation. So if the instantaneous angular velocity is omega, then the instantaneous linear velocity along the circumference is given as r omega t cap. If you do differentiate this further, then we get the acceleration vector a bar, which is the derivative of velocity. So here, while differentiating, we need to understand now that r omega is one variable, r is a constant, omega is a variable in r omega, and this t cap is another entire variable. So here we need to use the UV rule of differentiation. So by using the UV rule, we get, first we'll hold t cap as constant, we'll get r d omega by dt, and t cap I am writing as it is, as a constant. So d omega by dt happens to be alpha, but let me complete the derivative first. Plus I am holding now r omega as constant, and I am differentiating t cap. So the derivative of minus sin theta I cap happens to be minus cos theta. Mind you, d theta by dt also has to be written over here because we are differentiating with respect to time. I cap, and the derivative of cos is minus sin theta d theta by dt j cap. So this is the derivative of t cap. So now what happens is you take again d theta by dt outside, so you get minus r omega square, and then you get another vector cos theta I cap plus sin theta j cap. So this happens to be nothing but the radial vector or radius vector. You can check it out. It's along the radius. So it is nothing but r cap. So this vector t cap and r cap are the two vectors. R cap is along the radius directed away from the center, and t cap is along the tangent directed in the counterclockwise direction. So here we get, if we put d omega by dt is alpha, which is the rate of change of angular velocity, it is termed as angular acceleration. So you get r alpha t cap plus minus r omega square r cap. So if you do elaborate, you get r alpha t cap. So this acceleration component r alpha is along the tangent, and hence it is called as the tangential acceleration. It is responsible for changing the tangential velocity along the circumference. Plus minus r omega square r cap. So cos theta I cap plus sin theta j cap is a unit vector that is pointing along the radius in the outward direction. So this minus omega square r or minus r omega square is called as the centripetal acceleration that is directed towards the center. So it is the centripetal acceleration that causes the particle to turn and maintain its circular track. So this a vector is the total acceleration. So the total acceleration is a combination of the tangential acceleration at vector plus the radial acceleration ar vector, and the magnitude of the total acceleration will be written as magnitude of a bar is equal to under root of at the whole square plus ar the whole square. So this is calculus based analysis for a particle moving in circular motion, wherein omega happens to be the instantaneous velocity d theta by dt, and alpha happens to be the instantaneous angular acceleration d omega by dt.